thinking, and there is an F word out there that some people have used, and we're going to talk about the F word. Okay, I promise that you've heard it, and it's very similar to centripetal. And some physics teachers don't think that you should say the F word. I think that it's got a time and a place. Okay, but I know that when you're riding, if you were riding on this thing, or if you're in a car going around a corner, which way do you feel thrown?
Outside.
You feel thrown to the outside, but is it possible that you're accelerating toward the middle? Yeah, because that's the way acceleration always works, right? If I'm in my car and I accelerate that way, which way do I feel thrown? Backwards. So you always feel thrown opposite the direction of the acceleration. So if I feel thrown to the outside, I must be accelerating inward. Okay. So this is the centripetal acceleration is an acceleration that changes only the direction of a velocity, but not its speed. Okay. Why doesn't it change the speed? Magic. Is it possible that the force is at right angles to the velocity? Yes. For 4.5 billion years, the sun has exerted a force of gravity that is at right angles, on average, to the Earth's velocity. So the Earth isn't going faster or slower because of the gravity. It's just going in a circle. Yeah? Yeah, there we have it, right? Okay. So this is what we've got, is this notion, and we can just sort of divide it up, right? So far, when we've exerted a force on something, say it's moving this way, here's our velocity, right? We've exerted a force this way, which caused a negative acceleration, or a force this way, which caused a positive acceleration, right? In this case, we were changing the speed, right? But velocity is not just speed, is it? Velocity is speed plus direction. Either one is a change of velocity, right? So now we're talking about, if I've got a velocity this way, how do I make this thing turn right? If I'm going this way, how do I make it go in a circle clockwise? I make a force this way, don't I? Yeah? Right? And that will make, if the force is to the right, it's going to turn to the right. And if I exert a force this way, it turns to the left. I mean, it's really pretty simple, yeah? Okay, now we've got to sort out the fact that if, as we're turning left, we feel thrown to the right, right? But that's just normal. That's the way accelerations always work. So how about this? If I spin with this out at arm's length, which way is the ball going to go? Well, remember, the ball goes in the direction of acceleration, so it should go in or out, I think is what we're looking for. It's going to go in toward the center of the circle. Yeah? Should we try this? Here we go. Commencing rotation. Tell me soon, because I'm getting dizzy. Let's try the Cork. County Cork. It's on my side, isn't it? Yeah. Here, please tell me. Okay. Slowing down. All right. All right. Okay, here we are. Okay. So, I'm really dizzy. Okay. This is... So for this one, the direction changes. Right? And this is the one that we call centripetal acceleration. So that's what we're going to look at. We've already looked at uniform accelerations. In fact, all of our stuff is uniform accelerations. We're going to do uniform centripetal acceleration. What does that look like if you have a uniform centripetal acceleration? Yeah, you're in a turn. What are you doing? You're going in a circle, right? You're going in a perfect circle. The radius of curvature isn't changing. Your velocity isn't changing. Around and around you go. Okay? So that's perfect uniform centripetal acceleration. That's what it looks like. Okay? And then, now we need a formula, so let's get a formula for it, right? Let's make up a formula. Well, let's think it through. There's only two things we've got to put in our formula, the velocity and the radius, right? At a particular speed, what happens is you make the corner tighter. If you make r smaller, what happens to the g-force you feel? It's greater. It gets bigger, right? So there must be an inverse relationship. That is, as r gets smaller, a gets bigger. Right? It's got to be in the denominator, doesn't it? Yeah. Right? What about velocity? As I go faster, what happens to our... You go bigger velocity. Bigger g-force, right? So we've got to put the v up there. Now, does this formula work? Well, what are the units of acceleration? Meters per second squared. Does this thing come out with meters per second squared? Let's try it. Meters per second divided by meters is per second. Right? What is that? Is that the right units? No, so let's try v squared. Now let's try it again. Meters per second squared over meters. Does that work?
Yes.
That could be the right answer. It is the right answer. I've got a degree in physics. Just take my word for it. Okay, there it is. Okay, so this is our formula. V is our tangential velocity, right? R is our radius of curvature. Okay, also known as radius of curvature, right? In the same way Taryn is Taryn O'Neill, right? She's like, what? You're like, what? Here we have it. The radius, and so if you look at corners, right, the road is straight and then the road goes around a corner and then it's straight for a while. What they'll do is they'll make stretches of road, they'll make them all have the same radius of curvature. A well-designed road, they keep the corner, the radius of curvature the same, so you don't sit there with your steering wheel and have to, ooh, tighter, and not as tight, right? Yeah. The big exception to this, though, is that exit. If you guys ever gone from Highway 26, you're heading to Cannon Beach, and you get to 101, and you take the exit to Cannon Beach, you know what I'm talking about?
Yes.
Yeah, you come around and it says, slow down to 25, and you get in this big wide curve, and you're like, this is easy. I can go 50 around this thing, right? You're going 50, right? And then what happens? Yeah, right at the end it tightens. It goes like, nice, and then it goes, right? You're like, and then there's all these places where people didn't quite make it, right? They're like flying off of there like this. You can see like tire marks up the ramp. Wouldn't you want to be there when they do that? You know, it's like, you should put a camera there, just like fail blog. You know? It's a good sobriety test. I suppose it's a good way to make sure that drunks aren't driving on 101, right? Oh, you didn't make that one. Whoa. Okay, where are we? And then we've got a example problem. Whoa, look how fast you're learning. Boy, you're learning fast. Whoa, there. Here we have it. Okay, so the problem is, what is the centripetal acceleration of a 1,200 kilogram car going 24 meters per second around an 80 meter radius corner, which is, by the way, a very tight corner for, like the radius of curvature of the Terwilliger curves, I think it's like 175 meter radius, and that's a really tight curve for freeway. All of the other curves are like 300 meters, 400 meters are typical radii. Okay, so this is like an on-ramp or something like that, and we're going nearly 50 miles an hour, so this has to be fun, right? Okay, so 1,200 kilogram car, it's going 24 meters per second around a corner that's 80 meters in radius. Let's see if I can draw a small circle. Oh, that one's not so good. Okay. Still pretty good, but it's not, I'm not going to wax all poetic about that one, right? Okay, so 24 meters, this is 80 meter radius, and so I think all we have to do is plug into this guy and go 24 meters per second squared divided by 80 meters, and that's going to be 24 squared divided by 80. It's still 7.2. Okay. I noticed that the units meters squared over seconds squared divided by meters is meters per second squared, so that's just what we expect acceleration to be, right? Okay, and then the next question is, because why did I give you the mass? Well, we didn't use it, but now we will, right? The next question is, what centripetal force is needed? What force toward the center is needed? Gee, is there some way to relate force, mass, and acceleration? Yeah, just quit. Wait. F equals ma.
No, that can't be it.
No, it's F equals AM. So it's 1,200 kilograms times. Does this work? If it's an acceleration that's not speeding it up, does it still work for F equals ma? Yes, it does. By the way, if you are a car person, like you read like Hot Rod magazine or something like that, when they talk about okay, when they talk about lateral acceleration is Centripetal acceleration. Lateral just means to the side.